Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
At Grainger, we're for the ones who specialize in saving the day and for the ones who've mastered the art of keeping business moving. We offer industrial-grade supplies for every industry with same-day pickup and next-day delivery on most orders, all backed by real people ready to help. So you can get the right answers and products right when you need them. Call, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
This is Spacetime, Series 24, Episode 23. Coming up on Spacetime, high-energy neutrinos traced to a star being ripped to pieces by a black hole, Juno spots a meteor impact on Jupiter, and blast-off for the Cygnus 15 as it launches to the International Space Station. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have traced high-energy neutrinos coming from a star being ripped to pieces by a black hole in another galaxy. It's only the second time that scientists have linked the elusive particles to an object from beyond the Milky Way. The first confirmed high-energy neutrino source, announced back in 2018, was a type of galaxy called a blazar. The black hole's stellar feeding frenzy, catalogued as AT 2019 DSG, and technically called a tidal disruption event, occurred over 690 million light-years away in the galaxy 2 Mass X J20570298 plus 1412-165 in the constellation Delphinus. Tidal disruption events are incredibly rare phenomena, only occurring once every 10,000 to 100,000 years or so in large galaxies like the Milky Way. In fact, astronomers have so far only ever seen a few dozen. They're caused when an unlucky star strays too close to a black hole. The black hole's massive gravitational forces cause intense tidal perturbations, literally tearing the star apart into a stream of plasma. The leading part of the stream swings around the black hole, forming an accretion disk. Particles in the accretion disk are ripped apart at the subatomic level, releasing enormous amounts of energy. Eventually, these particles pass beyond a point known as the event horizon, beyond which they'll fall forever into the black hole singularity. But some gas from the hapless star at the trailing end of the stream manages to escape the system and ends up being launched by the black hole into fast-moving particle jets. And astronomers have long hypothesized that tidal disruption events would produce high-energy neutrinos within such particle jets. They also expected the events would produce neutrinos at peak brightness, whatever the particle's production process. But a report in the journal Nature claims the AT 2019 DSG event didn't evolve as scientists had predicted. This tidal eruption event was discovered on April 19, 2019 by the Zwicky Transient Facility, a robotic survey camera at Caltech's Palomar Observatory in Southern California. The study's lead author, Robert Steen from DESY, the German Electron Synchrotron Research Center, says astrophysicists had long theorized that tidal disruption events would produce high-energy neutrinos. But this was the first time that they've actually been linked through observational evidence. Neutrinos are subatomic particles. In fact, they're the most common particles of matter in the universe. But they have so little mass that they're extremely weakly interactive, rarely interacting with other matter. In fact, there are trillions of them passing through you right now, and you haven't even noticed. Astrophysicists are particularly interested in high-energy neutrinos, which have energies up to 1,000 times greater than those produced by the most powerful particle accelerators on Earth. They hypothesize that the most extreme events in the universe, things like violent galactic outbursts, accelerate particles to nearly the speed of light. And those particles then collide with photons or other particles to generate high-energy neutrinos. As part of routine follow-up surveys of tidal disruption events, Stein and colleagues undertook multi-wavelength observations of AT 2019 DSG across the spectrum. These included gamma-ray observations using NASA's Earth-orbiting Swift Space Telescope, X-ray measurements using the European Space Agency's XMM Newton Space Telescope, and radio observations using both the Very Large Array Radio Telescope in New Mexico and the South African Radio Astronomy Observatory's Meerkat Telescope. Peak brightness of the tidal disruption event came and went in May of 2019, but no clear jet appeared. According to the theoretical predictions, AT 2019 DSG was looking more and more like a poor neutrino candidate. But then on October 1st, 2019, the National Science Foundation's IceCube Neutrino Observatory at the Amundsen Scott South Pole Station in Antarctica detected a high-energy neutrino called IC 19-1001A and backtracked it along its trajectory to a location in the sky. About 7 hours later, the Zwicky Transient Facility noted that this same patch in the sky included AT 2019 DSG. Steen and colleagues think there's only one chance in 500 that this tidal disruption isn't the neutrino source. Because the detection came about 5 months after the event reached its peak brightness, it raises questions about when and how these occurrences produce neutrinos. Multi-wavelength measurements of each event help astronomers learn more about them as a class. So AT 2019 DSG was of great interest even without an initial neutrino detection. For example, tidal disruption events generate visible and ultraviolet light in the outer regions of their hot accretion disks. And in the case of AT 2019 DSG, these wavelengths plateaued shortly after they peaked. And that was unusual because such plateaus typically only appear after a few years. The authors suspect that the galaxy's monster black hole, which has a mass estimated to be some 30 million times that of the Sun, could have forced the stellar debris to settle into a disk more quickly than might have occurred around a less massive black hole. Also, AT 2019 DSG is one of only a handful of known X-ray emitting tidal disruptions. Scientists think the X-rays came from either the inner part of the accretion disk close to the black hole's event horizon or from high-speed particle jets. The outburst X-rays faded by an unprecedented 98% over 160 days. Interestingly, the authors haven't seen clear evidence indicating the presence of jets, and instead propose that rapid cooling of the disk most likely explains the precipitous drop in X-rays. But not everyone agrees with this analysis. Another explanation proposes that the emissions came from a jet that was swiftly obscured by the cloud of debris. Astronomers think the radio emissions in these phenomena come from the black hole's accreting particles, either in the jets or more moderate outflows. The authors of our study think that AT 2019 DSG falls into the latter category. Scientists also discovered that the radio emissions coming from this event continued steadily for several months and didn't fade along with the visible and ultraviolet light as previously assumed. The neutrino detection combined with the multi-wavelength measurements prompted Stein and his colleagues to rethink how tidal disruptions might produce high-energy neutrinos. The radio emissions show that particle acceleration happens even without clear, powerful jets and can operate well after the peak of both ultraviolet and visible brightness. And those accelerated particles could be producing neutrinos in 3 distinct regions of the tidal disruption. It could be in the outer disk through collisions with ultraviolet photons. It could be in the inner disk through collisions with the X-ray photons. Or it could be in more moderate outflows of particles through collisions with other particles. Stein suggested AT 2019 DSG's neutrinos likely originated in the ultraviolet bright outer part of the disk, based on the simple fact that the particle's energy was more than 10 times greater than that which can be achieved by particle accelerators. This report from NASA TV.
A team of observatories, including NASA's Swift satellite, recently joined forces to trace a hard-to-detect cosmic particle back to its dramatic origin. The particle, called a high-energy neutrino, was likely produced by a tidal disruption event, which occurs when a star passes too close to a black hole. There, extreme gravity causes the star to bulge and break apart into a stream of gas, with some of the material swinging around to form an accretion disk. Neutrinos vastly outnumber all the atoms in the universe, but they have almost no mass and rarely interact with other matter, so they're very hard to pin down. However, scientists have detected them coming from extreme objects like exploding stars. High-energy neutrinos come from even more bizarre places, like super-fast particle jets driven by supermassive black holes. Scientists suspected that tidal disruptions could also produce high-energy neutrinos, but they weren't sure where or when in the process the particles might appear. Some suggested powerful jets would create these neutrinos. Regardless of how they're made, though, astronomers expected they'd appear early on, when the event is brightest. However, a high-energy neutrino arriving from a tidal disruption called AT 2019 DSG offered new insights. An observatory called the Zwicky Transient Facility in California discovered the event in April 2019, but it wasn't until October that the IceCube Neutrino Observatory in Antarctica detected a high-energy neutrino astronomers linked to this event. Measurements by SWIFT and other observatories showed that the tidal disruption's visible and ultraviolet light peaked and appeared to plateau, and its X-rays dimmed quickly. However, radio telescopes saw its emissions steadily increase. This meant that some particles were being accelerated even though superfast particle jets were never detected. So, AT 2019 DSG had the right environment to accelerate particles and produce high-energy neutrinos, and maintained it for a longer period than scientists expected. Astronomers think the neutrino may have come from one of three regions. In the disk close to the black hole, where particles colliding with X-rays could produce neutrinos. Further out in the disk, where particles could interact with UV light. Or in broad outflows, where particles could collide with each other. This is only the second time a high-energy neutrino has been tied to a source beyond our galaxy. Scientists are searching for links between previous tidal disruptions and other high-energy neutrinos. And, as observatories discover new events, they now have a better idea of where and when they might find these elusive particles.
This is Space Time. Still to come, NASA's Juno spacecraft spots a meteoroid slamming into Jupiter, and the Cygnus 15 launches to the International Space Station. All that and much more still to come on Space Time.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
NASA's Juno spacecraft has observed a meteoroid slamming into Jupiter. The bright fireball was serendipitously discovered by the probe as it was studying auroral activity above the Jovian poles. A report in the journal Geophysical Research Letters says the flash was detected for just 17 milliseconds. It was detected by the spacecraft's ultraviolet spectrograph as an explosion in the gas giant's upper atmosphere. Jupiter undergoes a large number of asteroid and meteoroid impacts every year, but most are far too small to be detected from Earth. Since Juno arrived at Jupiter in 2016, it's detected at least 11 bright flashes lasting 1 or 2 milliseconds above the swirling Jovian cloud tops. But these have all been attributed to what are referred to as transient luminous events, an upper atmospheric phenomenon on Jupiter triggered by lightning. But unlike transient luminous events, the ultraviolet flash on April 10, 2020 lasted much longer, and it had very different spectral characteristics. Both auroral activity and transient luminous events have spectra featuring molecular hydrogen emissions, which reflect the primary component of Jupiter's atmosphere. However, this event had spectral characteristics far more typical of a meteoroid airburst in the Jovian atmosphere, about 220 kilometers above the cloud tops, and at a temperature of 9600 Kelvin. The authors say the brightness of the flash suggests an impact with a mass somewhere between 250 and 1500 kilograms. Juno's highly elongated 53 Earth-day polar orbit is designed to avoid as much of Jupiter's damaging radiation belts as possible. This allows the spacecraft to swoop down and skim just 3,400 kilometers above Jupiter's clouds before cruising back out to more than 8.1 million kilometers. To further protect the spacecraft from Jupiter's deadly radiation, Juno's most delicate instruments and control systems are housed in a specially shielded strongbox. The 3,625 kilogram probe is designed to study the chemical composition of Jupiter's immense atmosphere and cloud structure. It peers deep below the obscuring cloud tops, probing convection currents and the thermal engines driving its circulation patterns and its spectacular surface weather features, such as cyclonic storms and iconic salmon and cream-coloured atmospheric bands. Juno is also measuring Jupiter's gravity field to better understand its internal structure, as well as its magnetic field and auroral activity. Other than the Sun, Jupiter contains more mass than the rest of the solar system combined. So, by better understanding how the Jovian gas giant formed, scientists will learn more about the formation of the rest of the solar system as well. The largest impact to see in striking Jupiter is the now infamous Shoemaker-Levy comet. It broke apart during a 1992 close encounter with Jupiter before crashing into the planet in a string of impacts 2 years later in July 1994. The Shoemaker-Levy impacts left a series of Earth-sized scars in the planet's atmosphere and changed the planet's stratospheric chemistry. This is Space Time. Still to come, Cygnus 15 launches to the International Space Station. And later in the Science Report, a new study claims 1 in 5 diabetes patients admitted to hospital with COVID-19 will die within 28 days. All that and much more still to come on Space Time.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
A Northrop Grumman Cygnus cargo ship has successfully docked with the International Space Station 2 days after launching aboard an Antares 230 rocket from NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast.
5, 4, 3, 2, 1. We have engine ignition.
Main engine start. And we have liftoff up in Antares for NG-15 mission, the Wallops Flight Facility. Engines are at 100%. Attitude, core pressures, and vehicle subsystems are nominal.
The SS Katherine Johnson takes flight on this, the 59th anniversary of John Glenn's Mercury flight, carrying 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far.
Engines at 100%. All systems nominal. Good core pressures. Engines remain steady. Max Q. Attitude nominal.
First stage passing through the area of maximum dynamic pressure on the rocket. This first stage burns for a little over 3 minutes, 3 minutes 18 seconds until main engine cutoff.
Engines at 100% and steady. All subsystems continue in nominal performance. We'll be ready to shift down to 80% on the engines at 170. Start of slow throttle down.
Throttling down at 3 minutes into the flight. Main engine cutoff coming soon.
Throttle down to 55%. Main engine cutoff.
We have MECO. Antares entering into a coast stage. Fairing separation will occur about 30 seconds later. Some controlled firings on the interstage of the rocket.
Attitude nominal. Separation 20 seconds to stage 2 ignition. All subsystems nominal. Fairing separation. Interstage separation.
Confirmed fairing separation and interstage.
Stage 2 ignition.
Stage 2 ignition confirmed. Stage 2 is a solid rocket motor, burns for about 2 minutes 44 seconds.
Altitude 138 kilometers. Velocity 4.8 kilometers per second. Altitude 150 kilometers. All systems continue to perform nominally.
Good calls. 5 minutes 15 seconds into today's flight.
Stage 2 motor pressure nominal. Altitude is 170 kilometers. Roughly 1 minute to stage 2 burnout. All stage 2 and GNC parameters continue to be nominal.
6 minutes 15 seconds into the flight, coming up on stage 2 burnout of that solid rocket motor. That'll initiate a 2-minute coast period until second stage separation.
Stage 2 starting to tail off. Stage 2 burnout. Attitude nominal.
Stage 2 burnout, good attitude. We're in a coast period now. Cygnus exposed after that fairing separation, and will continue to carry the second stage with it until about 9 minutes into the flight.
Attitude nominal. Expected attitude control system thruster firings received. Continuing on course. Altitude 185 kilometers. Velocity 7.5 kilometers per second. All systems continue to operate as expected. Approximately 30 seconds to spacecraft separation. Systems continue to perform as expected. attitude corrections, maintaining expectations.
LCGSO, I just released red team to the pad.
Copy that.
Spacecraft separation.
Confirmed. 9 minutes into today's flight, Cygnus has separated from the second stage.
LC Ace, that concludes our callouts.
Copy that, Ace. Okay, NG-15, excellent job today. Let's go ahead and wrap up through this post-launch checklist.
The Expedition 64 crew on station used the orbiting outpost robotic Canadarm2 to capture the Cygnus upon its arrival and berth it onto the Unity module's Earth-facing docking port. The Northrop Grumman Cygnus 15 mission is carrying some 3,630 kilograms of supplies and scientific experiments. Included in the manifest is a new experiment using worms to study muscle loss in microgravity. There's also a study on how astronauts sleep in space. And there's a new environmental control and life support system. It's designed to improve air and water recycling for the station's crew. Also aboard is a new study called Spaceborne Computer 2. It's exploring how commercial off-the-shelf computer systems could be used on station to speed up the processing of data from experiments, cutting down the time taken for processing from months to minutes. The Cygnus 15 spacecraft will remain docked to the space station until May. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a Science Report. A new study has shown that 1 in 5 diabetes patients admitted to hospital with COVID-19 will die within 28 days. The findings, reported in the journal Diabetologia, examined the outcomes of 2,796 diabetes participants from 98 centres across France. Researchers found that within 28 days, some 1,404 patients, or 50%, were discharged from hospital with an average hospital stay of 9 days. However, another 577 participants, or 21%, died. Of the remaining patients, 12% remained hospitalized at day 28, while 17% had been transferred from their initial hospital. Older patients who had blood vessel problems, were short of breath on admission, and were not routinely taking metformin but were taking insulin, were the most likely to die. Over 2.5 million people have now died from COVID-19, and another 114 million have been infected since the virus first emerged from Wuhan, China, and spread around the world. A new study has confirmed that despite what people say on the surface, gay people who look and sound gay are more likely to face stigma and avoidant prejudice. The findings, reported in the British Journal of Social Psychology, also show that gay men who believe that they sound gay also tend to anticipate stigma and are more vigilant regarding the reactions of others. Scientists from the University of Surrey studied the role of essentialist beliefs, that is, the view that people have attributes that provide insights into their sexual identity. That is, straight guys are butch, lesbians are tomboys, and gay guys are queens. Of course, nothing could be further from the truth. It's all stereotyping, but it remains a constant in society. Researchers surveyed 363 heterosexuals, finding that most felt that the sound of a person's voice was a better cue to sexual orientation for men than for women. The authors also found that gay men who endorsed beliefs that people can detect sexual orientation from the sound of a voice and that speakers can't change the way they sound was associated with a stronger self-perception of sounding gay. Moreover, gay men who perceived their voices as sounding more gay expected more acute rejection from heterosexuals and, as a result, were far more vigilant. A new study has found that dolphins caught up in the BP Deepwater Horizon oil spill still have compromised immune systems more than a decade later, and even dolphins that were born after the spill are affected. A report in the Journal of Environmental Toxicology and Chemistry tested dolphins from around the area of the spill in the Gulf of Mexico and compared them with dolphins from unaffected areas. Scientists found immune system problems in dolphins born after the spill, which were similar to those seen in dolphins affected by the disaster. That suggests long-term consequences of oil exposure on the mammalian immune system and that the effects may even be passed on to the next generation. A new study has found that boys who regularly play video games at age 11 are less likely to develop depressive symptoms 3 years later. However, the findings, reported in the journal Psychological Medicine, also show that girls who spend more time on social media also appear to develop more depressive symptoms. Researchers reviewed data from 11,341 teens who were part of the Millennium Cohort Study, a nationally representative sample of young people who were born in the UK between the year 2000 and 2002. Researchers found that boys who played video games most days had 24% fewer depressive symptoms 3 years later, compared to boys who played video games less than once a month. This effect was only significant among boys with low physical activity levels, and it wasn't found among girls. But what researchers did find about girls and not boys was that those who used social media most days at age 11 had 13% more depressive symptoms 3 years later than those who used social media less than once a month, although they didn't find an association for moderate use of social media. Taken together, the findings demonstrate how different types of screen time can either positively or negatively influence a young person's mental health, and how it can also impact boys and girls differently. The authors had previously shown how sedentary behaviour appeared to increase the risk of depression and anxiety among adolescents. Now, speaking of tech, as we settle into our new faster 5G world, comes word from the tech giants that work's already started on the next generation of telecommunications. As Alex Zaharov-Reutt from ITWire.com reports, research into 6G is already well underway.
Well, it's due to arrive in 2030. That's about 10 years. Each generation has about 10 years whilst it's being developed, rolled out, improved upon, and there are different companies out there looking at 6G. But 6G work has already begun. China has launched some satellites into space with experimental 6G frequencies that they're working on, and Apple is looking for engineers who are going to help them to create these 6G standards in addition to all the other work that's being done around the world. Apple wants to own its own technology and have its own 6G modem. They don't want to be behind in the 6G race because just as 5G is transformational and will be powering billions of Internet of Things devices, you can imagine how much faster and better 6G will be. I mean, it should make wires completely obsolete. It should be absolutely ridiculously fast.
I can't wait for my iPhone 20.
That's right. So, look, it's still a decade away, but Apple is getting in early, looking for engineers. If you've got the skills and qualifications, Apple wants to hear from you.
And speaking of Apple, malware's been found on some Apple machines, both new and old. That's a bit of a shock. I didn't think Apple was victimized by malware all that much.
Well, certainly it isn't. Nowhere near as much as it is on Windows machines. But there is malicious code that can be found to run on Macs. And part of the news is that this has been written to be compatible with the new M1 or M series processors from Apple, that instead of using Intel chips, they have their own ARM-based chips that are souped-up versions of the same chips that you have in the iPhones and the iPads. And there's been a couple of reports of different M1-compatible malware. The second one is called Silver Sparrow, and researchers have found that this has infected nearly 30,000 machines across 153 countries, including big numbers in the US, the UK, Canada, France, and Germany. Now, they do say they haven't found any malicious payload as yet, but there is a delivery mechanism that could have some sort of malicious payload that could, for example, put a cryptocurrency mine or try and steal your usernames and passwords or pretty much anything. Once malware is on your computer, it's got control, or it can have control. The question is, how are these machines being infected? Now, there are vulnerabilities in older, unpatched operating systems that could be triggered simply by visiting a web page that has code that is looking for these older machines or older devices. Apple had to put out a release to iOS 14.4 a few weeks ago because there were 3 unpatched vulnerabilities, 0-day vulnerabilities that could infect your iPhone. And that's, a very worrying situation. It is dangerous, and people get infected on Macs either because they have old, out-of-date software that they haven't updated yet, or often people are also installing, be it, they used to have those pop-ups for Flash telling you that, you've got to get the new version of Flash. Well, Flash is now dead, but people are still being fooled by those. And also people who are downloading pirate software or pirate TV shows can find that either the software installers or some of the video files can be infected with something. And so it's risky to be getting pirate software and pirate content. I definitely would recommend against that. And also I recommend to use something like Malwarebytes for Mac. They have a free version and a paid version. The free version will detect and remove anything bad that it finds. The paid version does the same, but it does it automatically. It doesn't wait for you to first run the program and check. So, no computing platform is invulnerable to attack. And we can already see that Apple's new M1 processor is popular enough that the bad guys have developed malware for it.
Meanwhile, the NBN is continuing to grow and expand.
Yes, look, even though the government of Australia announced the NBN was effectively complete late last year, people are getting faster and faster connections on the NBN. There are now 8.1 million broadband connections on the NBN, and more than 5.5 million of those are 50 megabits or faster. Now, this is important because back in the mid-2000s, in the ADSL days, the average speed of connections was about 5 megabits. So if you're on a 50 megabit connection, that's 10 times faster. And many people are now on 100 megabit connections. And as we've spoken about in recent shows, people are now able to get 250, 500, and even 1,000 megabit connections, with gigabit or 1,000 megabit connections common in places like Hong Kong and Korea and Japan. Well, they're now available in Australia too. So the average speed and the types of connections that people are getting are faster and faster. And these days, when you're trying to watch Netflix and multiple people in the household are doing so, when your devices are backing themselves up to the cloud, when you've got to download big operating system updates to your phones and tablets, and even things like connected fridges and television sets all require updates too. It's important to have a big fat pipe with plenty of data that you can download as fast as you can possibly download it. And Australia is finally reaching into the 21st century and getting those faster speeds that we've wanted all along.
That's Alex Zaharov-Reutt from ITY.com. And that's the show for now. Spacetime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. Spacetime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the Spacetime store for a range of promotional merchandising goodies, or by becoming a Spacetime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Spacetime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our Spacetime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.